The motion of objects soaring through the air has been a source of fascination for scientists and curious individuals throughout history. In physics, projectile motion is a fundamental concept that unveils the captivating nature of objects propelled into the air, guided solely by the force of gravity. This article explores projectile motion, unraveling its core principles, delving into its mathematical formulations, and shedding light on its practical applications in the real world. There are some examples of projectile motion, which are projectile in volcano eruption, projectile in game animation, projectile in sport, and projectile in fireworks. So what is a projectile motion? A projectile is any object thrown into space upon which the only acting force is gravity. The primary force acting on a projectile is gravity. This doesn't necessarily mean that other forces do not act on it, just that their effect is minimal compared to the gravity. The path followed by a projectile is known as a trajectory. When a particle is thrown obliquely near the Earth's surface, it moves along a curved path under constant acceleration directed towards the center of the Earth. We assume that the particle remains close to the Earth's surface. The path of such a particle is called a projectile, and the motion is called projectile motion. After understanding what a projectile is, let us know the maximum height of the projectile. The object's maximum height is the highest vertical position along its trajectory. The horizontal displacement of the projectile is called the range of the projectile. The range of the projectile depends on the object's initial velocity.
Why do we use projectile motion in baseball? Projectile motion is highly common in sports since most games include the movement of a projectile, typically a ball. Using physics, we can calculate the best angle of a ball flight to maximize speed or distance. So in baseball games, projectile motion is used for both throwing and hitting. When a thrown ball is in mid-air, it exhibits projectile motion because the only force acting on it is gravity's acceleration. Baseball analysts can analyze pitches based on kinematics and projectile motions.
In the last round of a baseball match for the World Cup qualifier between Malaysia and North Korea, after being tied with 11 points, the last batter for the Malaysian team need to hit a home run to get the winning point for the Malaysian team. To perform a home run, the batter needs to hit the ball until it leaves the field. The distance between the batting plate and the fence at the end of the field is 110 meters. The batter hit the ball at an angle of 45 degrees above the horizontal with an initial speed of 35 meters per second. The ball is hit from a height of 1 meter above the ground. Assume air resistance is negligible. Calculate the time when it reached the maximum height, total distance of the ball, and determine whether the player managed to get a home run or not. And here is an example where we will apply the projectile motion. These are the steps how we will solve the problem. Firstly, we list down all information given from the question, such as the initial velocity and the angle of the ball being projected. Next step, we will calculate the time, which is t, when it reached the maximum height. At maximum height, we know that the Vy is equal to 0. So, to find the t, we will use formula Vy equal to Uy minus gt. To use the formula, we need to find the Uy first. From the triangle diagram, we can retrieve the Uy is equal to 35 sin 45. Next, we substitute the Uy value into the formula, and finally, we get t is equal to 2.52 seconds. Then, the third step is we will calculate distance of the ball after being hit, which is Sx. Formula we will use is Sx equal Ux times t. To use the formula, we need to find some value first, such as Ux and the total time t. For Ux, we can retrieve it from the triangle diagram, which is Ux equal 35 cos 45, and total time is 5.04 seconds. We times we times 2 the t to get the total times because the 2.52 seconds is half of the full projection. Lastly, we substitute back the ux and total time into the formula and get the total distance is equal to 124.73 meters. The last step is we need to determine whether the last player managed to get home run or not. So, since the total distance of the ball 124.73 meters is greater than the distance from batting plate and the fence 110 meters, then the batter is managed to hit a home run.
The physics behind objects traveling through air while being affected by gravity is known as projectile motion. Just picture throwing a ball, the way it curves is the ideal illustration. Gravity continuously draws it downward, yet the throw itself pushes it in a horizontal direction. Although we are powerless against gravity, we may manipulate the ball's trajectory and height by adjusting the throw's angle and force. Everything from the design of pyrotechnics that burst in large arcs to games like basketballs, where players aim for a target, demonstrates this. Projectile motion is used in even the most basic action, such shooting waters. Gaining an understanding of this concept helps us to enjoy the amazing world of motion all around us, in addition to helping us throw and aim.